Hello viewers, in this video we will discuss on the topic adiabatic process. In previous lectures we have discussed about the introduction of adiabatic process. We have yet some more points to be discussed in this adiabatic process. Okay, let us see. First, the equation of adiabatic process, PV per gamma is equal to constant. This we have discussed earlier. Okay, so here the equation is represented with pressure and volume. We have one more equation with respect to temperature and volume as PV power gamma minus 1 is equal to constant. This is also an adiabatic equation with respect to temperature and volume. So this could be represented for state 1 and 2 as T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1. Okay, so this is the equations. Okay, so the value of gamma is represented as equal to Cp by Cv. You know that molar specific capacity at constant pressure by at constant volume. So this gamma value is given in general form as 1 plus 2 by F. This is general form in which F is the degree of freedom of molecule. Degree of freedom of molecule. So what is this degree of freedom? This is the number of terms used to express the energy of a molecule. The energy of a molecule. The number of terms to express the energy of a molecule. Another definition, the number of ways the molecule could move, rotate and vibrate. So the number of ways the molecule could move, or the number of ways in which there is a translational motion, and the number of ways there is a rotational motion, and the number of ways in which there is vibrational motion. Because in case of this molecule, the degree of freedom is represented by the number of translational motion, rotational motion and vibrational motion. Okay, so this is about the degree of freedom. So degree of freedom in general we see that the number of motion possible. Okay, for example, let us take this object and I have a hole like this. So number of possible motion with respect to this object inside this hole is, we see that it has only a linear motion and also rotary motion. These two motions are only possible with respect to this condition. This is called the degree of freedom, the number of possible motion or possible movement. Okay, in general. So this is about in case of your molecule. Okay, degree of freedom in case of your molecule. So next, what are the types of molecules available? Okay, so here we have monoatomic molecule. Next we have diatomic molecule and polyatomic molecule. Okay, so monoatomic molecule, one atom for a molecule. Diatomic, two atoms for a molecule. Polyatomic, more than 3 atoms for a molecule. Okay, for example, we see that monoatomic, that is helium, argon. Some examples. For diatomic, we have H2, O2, HCl. Example, in case of polyatomic molecule, we have NH3CO2. These are some of the polyatomic molecules. Okay, so now we will see what is the value of degree of freedom for these kind of molecules. Okay, so we have the degree of freedom F for a monoatomic molecule as 3, for diatomic as 5, and for polyatomic as 6 or more than 6. Okay, 6 or more than 6. Okay, so if you know the value of degree of freedom, so next we can find the value of lambda, 1 plus 2 by F. So when you substitute this, we will be getting the value of the lambda for monoatomic molecule as 5 by 3. So which is equal to 1.66. In case of diatomic molecule, the value is 7 by 5, which is equal to 1.4. In case of polyatomic molecule is 4 by 3, which is equal to 1.33. Okay, so this is the value of your lambda. Okay, so next we have CV, constant volume, molar heat specific at constant volume. This is given by F by 2R. Okay, so this could be written as 3 by 2R, it could be written as 5 by 2R, and this is 6 by 2R. Similarly, we have Cp, which is equal to F by 2 plus 1 into R. So this is written as 5 by 2R, this is 7 by 2R, and this is 8 by 2R. So these are some of the values to be represented for various kinds of molecules. Okay, now I am going to write the slope of a adiabatic process. Slope of a adiabatic process. So to find the slope of adiabatic process, we take the equation of adiabatic process, that is PV gamma is equal to constant. When you differentiate this equation with respect to V, so it is written as P d by dV of V power gamma plus V power gamma dP by dV, which is equal to 0. So when you do the calculation for this equation, we will be getting the end result, that is dP by dV will be equal to minus lambda of P by V. So this is the equation of slope for adiabatic process. Okay. So now here we can see that the slope of adiabatic process. So already we have written, see that dP by dV is equal to minus gamma P by V. Okay, now I'm going to compare the value of the slope of adiabatic process with the slope of isothermal process. Okay, so the slope of isothermal process. So to find the value of slope of isothermal process, the equation of isothermal process is PV is equal to C. So again, differentiating this equation with respect to V. So it will be P dV by dV plus V dP by dV, which is equal to 0. So from this we can write dP by dV will be equal to minus of P by V. Okay, so this is the slope of your isothermal process. This is the slope of your adiabatic process. So when you compare this both equations, here we can see that the slope of adiabatic process is the slope of adiabatic process is gamma times the slope of isothermal process. So the slope of adiabatic process gamma times the slope of isothermal process. Okay. So when you represent in case of your PV diagram, because slope means that is the change of pressure with respect to change of volume. So that value you got with respect to the PV diagram. Okay. Isothermal, and this is adiabatic. So from this graph we can see that the slope of adiabatic process is more steepest when compared to the isothermal process. So the curve is more steepest, which says that the slope of adiabatic process is more when compared to your isothermal process. Okay, so that's it about adiabatic process. So these concepts will be very useful to solve many problems in your NEET and JEE competitive examinations. Okay, so have a note of it, and thank you.